In this video, I'm going to show you how Reloader can solve one of Kubernetes' biggest headaches, automatically restarting your application pods when the data that they rely on in ConfigMaps and secrets get updated. So as always, these lessons are completely hands-on. I'm going to provide you with all of the project files you need to follow along and have a fully successful product by the end. All right? So in module 1 of this lesson, we're going to set up the Reloader controller and give it the necessary permissions that it needs to monitor configuration resources in order to detect whenever the data inside of ConfigMaps and secrets get updated. Once we have that set up, in module 2, we're going to deploy a proof of concept. We're going to set up a PostgreSQL database pod with its usernames and passwords stored inside of ConfigMaps and secrets. All right. And then in module 3, we're going to update the data inside of these ConfigMaps and secrets. And I'm going to show you how the Reloader controller can automatically detect these changes and trigger a pod restart for our PostgreSQL database pods without any manual intervention from us. And so by the end of this video, I can promise you a successfully working automated deployment system, and I can't wait to see you in there. Let's do it. Welcome to Module 1. I'm going to zoom in and out of this diagram in order to direct your focus. So first, we're going to deploy the Reloader controller, and we're going to give it 2 sets of permissions. All right, so over here are the Kubernetes objects that we're going to be using to apply those permissions, but more importantly, we'll go through these later on, is the sets of permissions that we're going to give it. All right, so we're going to give our controller the permission to list, get, and watch config maps and secrets. So this effectively allows the Reloader controller to monitor our configuration resources and be able to detect when they get updated. All right. And when these resources get updated, we also want to give the Reloader controller the permissions to update and patch deployments, daemon sets, and stateful sets, effectively allowing our Reloader controller to watch for configuration changes, detect them, and then trigger pod restarts, whether those pods are being managed by deployments, daemon sets, stateful sets, doesn't really matter. All right, that's the gist of it. Let's go ahead and deploy our Reloader controller and give it all of these permissions. I'm going to explain every single step as we go along. As I mentioned, I'm going to provide you with all of the project files you need to follow along. I left you a link to this GitHub repository inside of your video description. Make sure that you go to it. Okay, once you're there, this repo, as it says, contains all the code needed to follow along with this tutorial that you're watching right now. Or this tutorial is also available as a written article for those that prefer to read, but I recommend watching the video first because obviously I'll go into more detail than this article will. Anyway, there are prerequisites. You should have a local Kubernetes cluster set up on your machine. I'm using Docker Desktop. If you want to have the same setup as me, feel free to go to this unlisted YouTube video in order to set that up. If you have your own cluster, that works as well. If you're new to Kubernetes, check out my Kubernetes training course. You'd also be supporting this channel by doing so. Anyways, let's go ahead and begin. We're going to start by cloning this repo inside of a directory of your choice. I'm going to clone it inside of the folder YouTube tutorial that I've got over here. So git clone the following. Okay, once you clone this repo, load it inside an editor of your choice. I'm going to be using Visual Studio Code, which is being a bit slow for me right now. All right. Go ahead and launch specifically this folder, and let's begin. I'm going to go ahead and start by spinning up a new terminal session, cd into the folder manifests, as it contains all the manifests we're going to deploy. Zooming in a little bit, and let's start. So the first manifest we're going to be deploying is the namespace. That one requires no explanation because the namespace demo reloading Demo reloader is where all the magic is going to happen. kubectl apply -f oo namespace.yaml, the name of the file itself. And so what are we going to deploy in that namespace? First and foremost, the Kubernetes objects that the reloader needs in order to automatically detect changes in config maps and secrets, and as a result, automatically reload application pods. How is this going to happen? First and foremost, we're going to give the reloader service account named reloader. If you previously watched my Kubernetes RBAC video, which is in this same DevOps training playlist, you'll know that a service account is essentially a badge that components in Kubernetes can use to identify themselves. Okay? So this badge that our reloader will use to identify itself, we need to give it the necessary permissions in order to monitor configuration resources and update application pods. We need to bind the service account to a custom cluster role. Okay? So the resources that our reloader needs permission to monitor are the secrets and config maps. Okay? And we're specifically giving it the permissions to list, get, and watch these resources. Simple as that. And then we go to the apps API group, where we can access the deployments, daemon sets, and stateful sets resources. So all of these are different Kubernetes objects that can manage a set of application pods, depending on whether these pods are stateless, stateful, or need to span every Kubernetes node. Again, we don't really care about that right now, but essentially here we're giving the reloader another set of permissions to list, get, and most notably update and patch any pods being managed by these deployment objects. Okay, so we've essentially given the reloader the two sets of permissions to monitor configuration resources and reset application pods as a result. How do we bind this custom role that we defined to the service account we're going to assign the reloader? We do that through a cluster role binding. And it's as expressive as I've made it out to be. We bind the reloader service account to the cluster role reloader role. Okay? If you want a more comprehensive explanation of role-based access control, make sure to check out my Kubernetes RBAC video, which is inside of the same playlist. So now that we've essentially set up the necessary role-based access control, now we simply deploy our reloader controller, which can be easily deployed as part of a Kubernetes deployment, and we assign the Kubernetes reloader controller with the service account name reloader, which is bound to the cluster role permissions that are needed to monitor secrets and config maps and update application pods. So by giving a reloader this service account, we're essentially done all of the instrumentation, okay? All we gotta do is deploy the reloader pod. It's gonna have all the permissions to do whatever it is that it needs to do, and then we can start working on our POC. So let's go ahead and say kubectl apply -f only RBAC and reloader for now, okay? So all the RBAC resources that the reloader needs, as well as the reloader itself. Simple as that. Now we can go ahead and say kubectl get pods -n demo reloader to see if the reloader is running properly. And indeed it is. It has all the necessary permissions to monitor config maps and secrets, the permissions to restart application pods. The next step is to deploy our proof of concept. Welcome to module 2. Now that we have the reloader controller all set up and given the necessary permissions to do what it needs to do, now we can deploy a proof of concept. So what we're going to do is set up a PostgreSQL deployment. All right, you can ignore all this. We're going to have a PostgreSQL pod by the end of all this. And the deployment managing this pod is going to be given annotations, specific reloader annotations that say whenever changes are made to the Postgres config map and the Postgres secret that this deployment relies on, reload it, effectively restarting the pod. And so then we go to the config map and secret that the PostgreSQL deployment relies on, and we annotate those as well with the following annotation to tell Reloader to watch them. And so effectively, now we've got an automated deployment system. Reloader is going to watch these configuration resources, detect any changes, and reload the corresponding deployment. Simple as that. Let's go ahead and do it. Okay, welcome to Module 2. In Module 2, we're just going to go ahead and deploy our proof of concept. But before doing so, I want to direct you to the following annotations that have been applied to the config map and the secret that our PostgreSQL application pod relies on. So these annotations effectively make the secret, Postgres secret, and the config map, Postgres config, discoverable by the reloader that is running inside the same namespace, such that whenever changes are made to this config map and secret data, whenever changes are made to the password or to the database and username, Reloader will be able to automatically detect these changes. Okay, so we've given the configuration resources the necessary annotations to be discovered, to be monitored by Reloader, which has the permissions to monitor configuration resources. Now we give the application pod itself annotations, specific Reloader annotations saying, hey, Reloader, whenever you detect any changes made to the Postgres secret, any changes made to the Postgres config, go ahead and reload my pods, essentially reloading the Postgres container pod that's going to be running as part of this deployment. And here you can see this Postgres application pod relies on Postgres secret for a password, Postgres config for a username and database name, and whenever changes are made to these, Reloader is automatically going to detect these changes and reload the Postgres application pod. So now we have enough to deploy our proof of concept. And before we proceed, I also included a Postgres client that we can use to test and verify that everything is working as it should. So all this has is a very, very simple container that grabs the Postgres password from the Postgres secret, the Postgres user and database from the Postgres config, and tries to authenticate to the PostgreSQL pod that we have running as part of this deployment. If it does, it's going to output successfully connected to PostgreSQL. All right, that's pretty much it. The idea is that at first, when we deploy all of this together, it should successfully authenticate. But then when we update the config map and secret, that pod is going to be updated to now have a new username and password. And therefore, this will start failing to authenticate. So if it fails to authenticate, that means that the reload was successful. All right, that's pretty much it. So let's go ahead and deploy everything. I'm going to say kubectl apply -f 03 postgres config.yaml 04 postgres deployment.yaml 05 client.yaml. Simple as that. See you in module 3. Welcome to module 3. So now everything is all set up. The only thing we need to do is to update either a config map or a secret, see that Reloader actually detects these changes by itself, and then automatically restarts a pod. All right, I'm going to have a separate terminal which shows the pods automatically restarting without any manual intervention from us. Let's go ahead and do it. All right, so all we're going to do in this module is update the config map and secret, verify that the Postgres pod gets reloaded as a result, and then verify that the client fails to authenticate once the deployment is updated to have new credentials. Okay, so before we do that, what I want to do is start up a new terminal session over here. You should do the same as well. Here I'm going to say kubectl get pods dash n demo reloader, and I'm going to add a -w flag so that we can watch everything that's happening in real time. Actually, before we do that, let me just show you that at first, this is able to successfully authenticate using the existing credentials in the ConfigMap in secret. So kubectl logs -f. We'll stream the logs for this pod in the namespace demo reloader. All is well. Okay, now let's watch everything happen in real time. As soon as, this is too messy. As soon as I update the Postgres config map to have a new database, our Postgres pod is gonna be reloaded because we've updated this configuration resource. So let's go ahead and say kubectl apply -f06 config update.yaml and watch our reloader detect this change, create a new pod for our Postgres deployment, and it's going to shortly terminate the old pod. All right, and now that that's all completed, we now have a new Postgres pod that's been updated to adopt this new config map that it relies on for configuration. And so now we can go ahead and apply this secret update. So now essentially, we've given Postgres a new password for authentication. And as a result of updating the secret, Reloader is going to detect this update, run a new PostgreSQL pod, and terminate the old one. All right, and now what I can do is say kubectl get pods without the watch anymore, and Postgres was just updated, reloaded to adopt the new credentials and the configuration resources that it relies on. All right, how do we make sure that it's actually using those new fields? Well, I can stream the logs inside of the client as before, and it should start failing because it's using the old password and username that it was initially able to load from the old secrets and config map. So if we actually reapply the client, or let's delete the client, delete -f05 client.yaml, deleting the resource that originated from this file, reapplying it again. So now it should grab the updated password and user from the credentials and be able to successfully authenticate to our updated database. So if I stream the logs for the new pod, I'm going to need to get that pod -n demo reloader. We'll say kubectl logs -f stream the logs for PG client. Amazing. So before we wrap up, let's just go ahead and clean everything up. So I purposely did everything in one namespace so that by virtue of deleting the namespace, demo reloader, we've essentially cleaned everything up. Hope you enjoyed this video. If you do, please feel free to hit that subscribe button. And if you want to support this channel, make sure to check out our Kubernetes training course. See you in the next one.